shear force and bending moment diagrams. Then topic 4 is the analysis of trusses. Topic 5, the geometric. Topic 5 is geometrical properties of cross sections. And then finally, topic 6, which is fundamental concepts of dynamics. So in simple terms, we are going to discuss two major branches of mechanics: static mechanics and then dynamic mechanics. Mode of delivery, this is not, of course, the only difference now is delivery is, as of now, still online, but including discussions, demonstrations, illustrations, tutorials, assignments. Practicals are going to be a little bit given that we cannot meet. So this is how I propose we do the assessment, group assignments, 10%. You can note that down and then discuss it later. Tests, 20%. This 10%, definitely 100%. That is as per the proposal I have. It's open to discussion and you can always proceed. So these are some of the references. Those that I do have, I'll share with you. Those that I do not have, I will always let you know, but I'll try to, as much as possible, to look for them so that you have a glimpse. So, introduction to mechanics. Like I already said, the actions of forces on the actions is what we are going to interest ourselves in. And that is what we are calling mechanics. So, when a body is not having any effect, in other words, its own weight, then those are what we usually call the dead forces. My own weight is a weight my skeleton is naturally designed to carry. But in addition to my own weight, there is some extra weight that I can carry before my skeleton is damaged. So it's the same thing with structures. If we have a column, let's say a column, by now we all know what a column is. If we have a column of, let's say, 100 millimeter diameter, if it is circular, the load it can carry is not the same as a column which is 500 millimeter diameter. Of course, that will depend on, apart from the size, even the height of the column is important. How high is it? You can actually have a column which is 500 millimeter in diameter fail due to its own weight. Why? Maybe because it is too high. So this cause, for example, if you tied a rubber band and you try to pull it, actually this can be practical. If you tie a rubber band and you try to pull it gradually, with little effort or little force subjected to it, you tie it at the one end and then you pull it. You realize it stretches until some point, which point if you exceed, it will have no option but to fail. So it fails by breaking and what you get in engineering. So our intention now, if we are looking at the test scenario of the rubber band, our intention would now be what is that we can subject, it fails. Okay? So we design knowing that if this rubber band can fail at a force of 5 kilonewtons, then we should not exceed 5. Because it means any force that is equal to 5 or beyond 5 will cause the rubber band to fail. So the same thing, that is usually the intention. And now we will be seeing other things to do with sizing. So, of course, when we are talking of the force, then acceleration, the principles of acceleration will come into play. Acceleration due to gravity, that value by now. We know, but if it is not, we prefer. Some people prefer using mass 10 meters per second squared. The issue that is of great importance when it comes to concrete technology, the units. The moment you do not give attention to the units, then you are with correct numerical calculations, but wrong final answers. Why? Because you did not remember to standardize your units. And that is why we are saying, under the course, we must appreciate this. So, of course, these mechanics we are looking at the behavior of the material when subjected to a force does not only stop when it comes to structural engineering, it cuts across to fluid flow, molecular, atomic, and subatomic behaviors. All these are different categories of engineering. But for us, our interest is mainly driven towards the structural design. At this level, our interest is to know how does the material behave when subjected to a force of this magnitude. So this course is divided into two branches. Engineering mechanics is subdivided into two major branches. The first one being static or statics. And for this course, it actually takes about 80 to 90%. This is a course where we are going to study about bodies which